Look at these numbers and try to find out prime numbers as fast as you can. Well, what would be an approach? Probably scanning through the numbers one by one and noting down prime numbers. But how do we identify if a number is prime or not? The basic approach is to divide that number with all numbers less than it except 1 and the number itself, and check the remainder in each case. If it is never 0, we call it a prime number. But for a bigger number, say 1517, it becomes hectic to do this process for us. So using computers to do this task for bigger numbers is a good choice. To do this task, we need to instruct the computers. To instruct, we code. But to code, we need logic. And having a good, elegant logic is important, and this is where the algorithms come in. Algorithm is nothing but flow of logic. It's like start, step 1, step 2, step 3, end. That's it. And we put the logic into the steps. Let's understand algorithms by making one. We will design an algorithm to find if a number is prime or not. For this, we let the user give us the number to be scanned. If it is prime, we print prime, and if not, we print not prime. So let's begin. First, start. Then we take an input from the user and call it n. So if the user inputs 5, means n equals 5. Then we need to divide the number n repeatedly with numbers less than it. So we will initialize a variable called div, meaning divisor. Initialize means we are declaring something and setting its initial value. Here, in this case, we will start with 1 as initial value of div. But we need to start dividing from 2. So let's just increase value of div by 1. Plus equals means we are updating our div by adding some value. So we have div equals 2 now. Let's start dividing. But we are concerned with remainder, not division. So we will just calculate remainder, and in many programming languages, percentage sign is used to get the remainder. Now let's apply condition n percentage div equals 0 or not. If the condition is true, means we got remainder 0, so it must be a prime number. So for in case of true, we print not prime. If the condition is false, means n does not give remainder at 0 with div, then we need to check for the next divisor. So we jump back on div plus equals 1. And now we have our next divisor. This loop goes on. But we need to set limit for the divisor as well. That is, it must not exceed than n minus 1. So after the condition of remainder is false, we assert one more condition. Is div less than n minus 1? If it's true, means we are not yet done with dividing. So jump back to div plus equals 1. If false, then we are done with dividing by all numbers, and then we are ready to declare our n as prime number. It's always a good practice to verify the algorithm by taking some examples. Let's say the user inputs n equals 7. So div equals 1, now div equals 2. Is remainder of 7 by 2 0? Well, no. Is div less than n minus 1? That is 6. Yes. Then jump back to div plus equals 1. Well, our algorithm works. But there's a catch. What if user inputs n as 2? Think about what our algorithm will give, and if the results are incorrect, ponder upon how to deal with these edge cases and comment down the approaches. Thank you.